Welcome to learneasy.org. We'll have our next topic, that is DXF, data exchange format. So data exchange format is a file format for graphics information. So I'll say what exactly it is. So DXF has been first developed by AutoCAD in the year 1982 for their AutoCAD 1.0 version. So what exactly is, it's an ASME, and ASME is American Standard of Manufacturing Engineers, and ANS is American National Standards Institute standard that is used for PC based CAD/CAM platforms. CAD is computer design 2D, so AutoCAD is 2D designing software, and CAM is computer aided manufacturing software. So for PC based, we are on desktop PC based CAD/CAM platforms, we will be using data exchange format, that is DXF. Now DXF enables vector data exchange as well as 2D and 3D graphics drawing. That's an important point you have to know. That is DXF, that is data exchange format, enables vector data exchange as well as 2D and 3D graphics drawing. So this is what this is a definition. Okay, this you have to make simple. See, in both this video, the earlier video, on this video, I'm not going into deep about everything because it takes much time which cannot be covered in a video, or you'll be getting bored to listen to video or either. So I'm covering these outlines which can help you to at least write something for the examination. Okay, your paper won't be left blank. Okay, you can write something out of it. So these are the basic things you have to learn. If you could watch this video again, you will learn what is on both these videos. You can learn what are the basics and how we have to write. Okay. Now again I'll repeat, the DX is a data exchange format and is a file format for graphics information. So you know what is graphics. In the last video we have seen what is graphics, and then it is ASME, and see, ASME is American Society of Manufacturing Engineers, and ANSI is American National Standards Institute standard that is used for PC based, that is a personal computer based CAD/CAM platforms. Okay, DXF enables vector data exchange as well as 2D and 3D graphics drawing. So we can exchange 2D drawing or 3D graphics drawing. You can exchange between two computer systems. Okay, and it is invented by Autodesk for the AutoCAD version 1. Why the reason DXF was introduced earlier? The drawings of AutoCAD is stored in DWG drawing format. Even now it is in DWG format. But before DXF was introduced, the file transfer was a little bit difficult. They were not able to transfer the files between one system to another system. Okay, so the main advantage of data exchange format is interoperability between AutoCAD and other programs. You know AutoCAD is a 2D designing software. Most of you have worked in AutoCAD earlier. Okay. So, and one more thing, if some of you haven't worked with AutoCAD, I can give you just get some older version of AutoCAD, maybe AutoCAD 2009, 6. The previous older versions, 6, 7, 8 or 9 all will work. And all this previous version is better for you to prepare for the first time, and don't go for AutoCAD 16, 15 or 13 or something. It might, it is more sophisticated, more comfortable, but you have to learn from the basics. You have to use AutoCAD 2009, 10. You can self-learn. Once you are better with self-learning, then you can go with AutoCAD 2016 or 17 or whatever it is. Fine. So now this is why this DXF is introduced, is to create an interoperability between AutoCAD and other programs. So now once an AutoCAD drawing is done, it will be transferred to Proe or CATIA for 3D projection, or into like C Sharp. I think C Star is alliances or into answers for structural analysis, either into analysis in software or into a 3D projection software. Now the file changing or transfer of files is made more easy with this data exchange format system that is introduced by AutoCAD. And main reason is for interoperability between AutoCAD and our programs. Okay, I hope you are clear with DXF, why it is, what for it is, and how it is. Okay. Now we'll go with again I understood a point here. There is no information stored on units. So normally when a drawing is saved, it is deep in the hardware. It is stored in form of units 1, 0, 1, 0, 1, or 0, 0, 1, like binary formats or something. But here no information is stored on units in DXF format. No information is stored in units. Okay. Now we'll go for OpenGL. OpenGL is Open Graphics Library. You know what is a library? You have in your college, you have a library where you have a collection of books, volumes of books, different books, novels, short stories, core books, etc. Now OpenGL is a library of Open Graphics. Open Graphics library. It's a cross-language, multiple language, cross-platform application programming interface, API. What it is? Application programming interface. Okay, cross-language, cross-platform application programming interface for rendering 2D and 3D vector graphics. What is rendering? Means running. What is a running or projecting or visualizing? Anything can be some rendering graphics. Most of you all might be playing PUBG. Have you ever imagined how this PUBG is working in our mobile video game? How this video game is working? Or this is a lockdown period. Most of you are playing games in your PC or mobile. Most preferably mobiles. MPL games, Rummy, X or Y these are games. How have you ever imagined this is an AI or we say this is all gaming softwares, animation softwares, it's all based on computer. And if that was it concept you are mistaken, yes, of course you have AI technology over there, gaming technology over there, but at the end of the day, you have a lot of mechanical concepts. That's why we say mechanical engineers are everywhere. We say A to Z industry, mechanical engineering can be right there. Okay, now so rendering 2D and 3D vector graphics, we use this Open Graphics Library. It's a cross-language, cross-platform application programming interface API for rendering 2D and 3D vector graphics. Okay, I think you have noted this. If you want to clear it, you can take a note of it. And we have the block diagram here. Evaluator, okay, EVALUATO or evaluator. Then pre-vertex operation and evaluator to the pre-vertex operations primitive assembly. Pre-vertex, PREVERTEX, pre-vertex operations primitive assembly. Okay, then rasterization, RASTERIZATION, and pre-fragment operations, and from pre-fragment operations, PREFRAGMENT operations, pre-fragment operations to frame buffer and frame buffer to pixel operations, again from pixel operations to texture memory, and again texture memory to rasterization, and here again display list to pixel operations. Now you see why. I'm just seeing a block diagram. Okay, what exactly this difference? It is very simple, and this is how a OpenGL works inside a hardware. In a hardware system, how the data file is being exchanged or the internal operation is displayed inside is displayed by means of a block diagram. Display list, how it works. It is a display and an evaluator, pre-vertex operations. Okay, this you can see. So you can have this exact data as PDF file in Learn or website as well. We will be uploading all these assignments. We will be uploading all these classes, offline definitions. So explanation you can find in our website. You can download it. So already a lot of online university subjects are always the notes are available in SlideShare, and you may come across padips.net. A lot of open source platforms are there to download. You download, enjoy, but what you have to do is we have to download it and we are again uploading it in the learn.org platform. No, we have our unique materials as well as downloaded, pre-downloaded materials as well. That's for your easy reference. You need not search where it is. Everything you should have in your hand steps. So we will be uploading both our own resources as well as pre-downloaded resources. You can find both these resources in our learn.org platform. So you can get an easy access of. Also, we have assignments as well. So I will say what as a benefit of assignments. We will be sharing a few assignments, and if you could complete the assignments, and based on that, you will be winning in certain prizes. Learn.org, or if you are using your college platform, if you are, for example, if you are a student of XRY college and if the particular college is subscribed to us, what you will be getting is that you will be completing an assignment. You will be downloading all the resources from our website. You will be completing the assignment. Either you can send us through a mail ID, or you can drop it directly. Your assignment marks will be credited directly to the college. Now, during this is offer during lockdown periods, maybe there's no possibility that you cannot go to college and you can complete the assignments, but you can download the materials, you can complete the assignment, and you can send back to us, and it will be taken back to your respective colleges, and you will be getting your assignment marks done. So through our platform, we are enabling the institution as well as the students. Okay. Now this is to say the DXR is done, and OpenGL is done, and now we will go with IGES. IGES. Don't read it as IGES. It's IGES. Okay. IGES is a neutral file to transfer 2D and 3D images. So what is neutral file? It's a neutral file. It does not what we can say exactly. It does not depends on any core software platform. Okay, it's a neutral file. Neutral file, not no DWG, no DXF format. It's a neutral file. You know what is neutral? It's not dependent on any files. Okay, it's a neutral file to transfer 2D and 3D drawing between two dissimilar CAD systems. That's a very important point. Between two dissimilar CAD systems, not similar computer-aided design. Because, for example, it's not between CAD to CAD, AutoCAD to AutoCAD. This AutoCAD to some other 2D or 3D drafting. So, a lot of 2D and 3D drafting software from one 2D to different CAD software, not in the same CAD software. So, I hope you can understand. What IGES is a neutral file to transfer 2D and 3D images and drawings to a dissimilar CAD system, not a similar CAD system, dissimilar CAD system, which means in the system A you have AutoCAD, and in system B you have some other 2D or 3D software. So dissimilar CAD systems. Okay, and there are two types. One is fixed length ASCII. One fixed length ASCII code of 80 characters. Okay, fixed length ASCII code of 80 characters, and we have the compressed ASCII. Two types. Okay, one is fixed length ASCII code of 80 characters, and the next is compressed ASCII. Okay, two types. And next is step. Yes. Now we'll have a look at a step. Step is again a CAD file format used to exchange 3D images to a different CAD system. In the previous one, we will be transferring 2D and 3D images to a different CAD system. Now in step, we will be transferring only 3D models between users with different CAD systems. I'll repeat this. Step is a CAD file format, computer-aided design file format, usually used to share 3D models between users of different CAD systems. So, different CAD systems. Standard for exchange of product model data, that is STEP. It's a more complicated explanation or a complicated abbreviation of this STEP. Standard for the exchange of product model data. This is how we will write a step file. Step file ISO 103031. Okay, this is a format, same common format. In a CAD system, we are typing this step file ISO 103031. As soon as we type this, it goes to the original file, or the corresponding file will be displayed. The corresponding design will be displayed, where we can check or we can do any corrections as and when it is required. Okay, I hope everyone will be clear with what is step. Now we have a small block diagram about this. Step 1 is application protocol, layer 3. Okay, layer 3, we'll go 3, 2, 1. Layer 3, layer 2, layer 1. Layer 3 is application protocol. Layer 2 is resource information model. Layer 1 is implementation methods. And finally, we have physical files. So, what is layer 3? Application protocol. How we are going to, what method or how we are going to develop the product data. And next is resource information, whether we have all adequate resources, dimensions, requirements clear. And layer 1 implementation, how we are going to implement it. And finally, physical files. And all this layer 3, 2, 1 is interconnected to a confirmation, testing, and framework. We have to confirm, okay, our design is correct. It is based on the customer's requirement. It matches all the specifications. It matches all the design data. There is a conformance testing and framework. Okay, this is simply the complete overview of a step. And next is CALS, CALS, CALS. So again, I said it's been developed by US Defense Force, and it is computer-aided logistics support. And there's another definition, computer-aided life support. So there's a contradictory statement. We have still authentication. We have to still authenticate. We have to still authenticate what is correct. But we'll go on with computer-aided logistics support. Basically, why US Defense have formulated this is to track down the logistic movement. So maybe how much arms and ammunition have been moved, or like this. No, this is our determination. And now we'll have a data for it. First is needs and requirement. It's now going to product design. Needs and requirement. Why? What's the purpose? Need and requirement, and then to design. In design, we have conceptual design, we have preliminary design, we have detailed design. What is conceptual design? Concept. We have a design concept. We have to design something. We have to manufacture something. We say, I have a concept. Well, now that is a conceptual design. Then is the preliminary design. This is how it works out. That's a preliminary design. You will simply, if you have a concept, what you will do? First, you take a paper and you will draw how the product looks like. Am I correct? Simple. You will draw a paper. You will drawing something in a paper if you have a concept or if you design. For example, if you think you are going to design a car, first what you will be doing? You will be taking a paper and you will be drawing the shape of the car, how it looks like. Likewise, there is a preliminary design and then detailed design. The detailed design, you know, 2D or 3D. What is a detailed design? And then is from design it goes to the production and construction. We are going to produce the product or we are going to construct the product. There you have the manufacturing and assembly. We are manufacturing the product and we are assembling the product. And finally the case is operation, maintenance and support. We are operating it, we are maintaining and support. And this all comes under CALS course. Okay. So hope we'll catch up in the next video.